Hi, my name is Junko Yoshida, Editor-in-Chief of the Ojo Yoshida Report. Thank you for joining us today for this session on the anatomy of software in software-defined vehicles. We will offer you this panel in a pre-recorded video format. However, please note that right after this video, we will have a live Q&A session with the Sonatus CEO, Jeff Chou. Thank you. Whatever your vision for software-defined vehicles, get there faster with the enabling technologies from Sonatus. Our market-proven software serves as powerful building blocks that empower automakers to realize dynamic SDV architectures. Sonatus, accelerating the shift to software-defined vehicles. Learn more at www.sonatus.com. Hi, everyone. My name is Junko Yoshida. I'm the Editor-in-Chief of the Ojo Yoshida Report. Today, we have a fabulous guest that we put together, we meaning Ojo Yoshida Report and the Sonatus, put together this special panel on software-defined vehicle. Our focus here, however, is software. I put it like, I'd like to know the anatomy of software in SDV. Everybody talks about SDV, software-defined vehicle, but I think it's kind of unclear what software-defined vehicle is and what software we're talking about. But before diving into the panel, let me introduce first my partner here. Jeff is the CEO and co-founder of Sonatus. Hi, Jeff.
Hello, and thank you for having me on. And I'm very excited to be here and talk about one of our passions, which is software. And I'm very excited to be joined by our friends and I'll let them introduce themselves, from other leading companies around hardware and software and thought leaders.
All right, very good. Moving on, I think we go by the alphabetical order by the company. So let's go with the Robert Day from ARM. Please.
Hi, Junko. Hi, Jeff.
Yeah.
Appreciate you having me on. Yeah, my name's Robert Day. I work in ARM's automotive line of business. I also am ARM's representative on the governing body of SOFI, which is a software initiative particularly relevant to software-defined vehicle.
Very good. And then we move on to the Elektrobit, that Dr. Moritz Neukirchner, right?
Yes, good. Yes. So, hi, my name is Moritz Neukirchner. I'm with Elektrobit and a senior director responsible for strategic product management in the field of SDV. And we specialize in software solutions for vehicles. So this is really a home turf topic for us, and we're excited to talk about it.
Very good. It's in your wheelhouse. That's good to know. And the next, and not the last, is Ray Cornyn from NXP. Hi, Ray.
Hey, Uncle. Great to see you. Great to see everybody from the team. So I'm Ray Cornyn from NXP. I run the Automotive Processor team, and we're working on a lot of the new hardware that's going to run all of this new software-defined vehicle software. So great to be part of the discussion, and thanks for inviting me.
Thank you. All right. So I really want to go dig deeper into the software part of this discussion. But before, to set the stage and set the tone, I would like to ask everybody on the panel what software-defined vehicle means to you. Do you want to start, Jeff?
Sure. First, a bit of perspective that I think one of the things that we bring here at Sonatus that might be a little different is many of us came from the world of IT. So myself, I worked on data center, cloud, service provider infrastructure, and software-defined technologies arose out of that industry. Back in 2005, I think a paper from MIT really talked about what a software-defined network was. And then it expanded to other institutions in academia. And I was at Cisco at that time, where we delivered software-defined networks. And then we went on to talk, to basically introduce products around storage, around cloud. And at that time, software-defined really meant being able to orchestrate and to control different aspects of hardware in an abstract way that allowed more and more people to participate in the ecosystem. Now, fast forward, I think some of those principles remain in automotive, but that definition has expanded. And now I think if you talk to 10 different people in automotive what software-defined vehicle means, you'll get 15 different answers. And I think our approach is that we feel that this is an open discussion and everybody is right, because this is the ecosystem where everybody is involved in, and is expanded to talk about now cover every layer of every aspect of software in a vehicle. And we agree with that. I think there's room for everybody to innovate here. Where Sonatus views our participation in the software-defined vehicle movement is we're all about kind of that middleware aspect and what we call infrastructure services. So it's about connecting vehicles, it's about updating vehicles, it's about enabling flexibility in vehicles, it's about allowing vehicles to be data-driven, right? Where OEMs and tier ones and all the suppliers and everybody in the ecosystem relies on data to make decisions about technology, about features, about how they run their business. So all of those things combined are essential in our minds of a software-defined vehicle. And ultimately, that delivers what we think is a platform for innovation, right? So to us, the end all and be all of a software-defined vehicle is that it is a platform that changes and that enables more and more innovation.
All right. Jeff covered a lot of ground on the SDV just now, but I'm going to ask Robert here. What do you see? I mean, ARM is not exactly a OEM, right? And you're not exactly a chip company either. You're the IP vendor. So tell me what SDV means to you.
So Junko, it's really interesting because in the automotive world, we've traditionally looked at modules or ECUs powering the vehicle. That's kind of the traditional way. And yeah, there was some software in there that was doing some of the magical stuff, but it was more, hey, we've got this box here that does this function. What we're seeing now is with the software-defined vehicle, it's going to be the software which may or may not run on an ECU. It may well run on some different architecture within the vehicle. And this software is what's going to power the different functions within a vehicle. And this software is going to have a life. So unlike now, where a module is your module and that's what goes in your car when you buy it, now the software-defined vehicle is going to be an updatable, an upgradable, a changeable a set of functions in a vehicle. And that's kind of the really interesting part, is how does one achieve that? How does one shift an industry from being kind of module driven to being software driven? And hopefully we'll talk a lot about that today.
That's great. All right, I'm going to go to the Moritz. Tell me about what you see in SDV.
So when I look at it, I think about what's going to be the value for the customer, for the end customer who actually buys a car. And when I look at it today, when you buy a new car and you drive off the dealership, it's the best car it's ever going to be. After then, it's only going to be downhill. This is what we want to change. So it's not just about adding update capabilities to roll out the next security patch. It's not about just adding more software. This is what I would call software enabled. So when I look at a rocket that goes to space, that's software enabled. Can't build it without software. And well, it is a rocket and it's going to stay a rocket and not change significantly. So what software-defined means for me that you can actually change the key functions or the nature of a device through changing its software. And I think this is what we've seen in the smartphone market so much. Right now, all smartphones pretty much look the same. And do you really care about what your smartphone is? You care about the ecosystem of functions that the smartphone brings. And this is the fundamental transition that we now want to make in automotive, to actually enable to change key functions of a vehicle. Yes, the vehicle will remain a mobility device. It's not something that you are going to put in your pocket. But the point that you actually bring new value and new innovation. So as Jeff said, looking at it as an innovation platform, that's really at the core of a software-defined vehicle. And I think this is really, and this is where I have to not agree with Jeff. I don't think all definitions are right. There's just too much noise in those definitions, too much overloading of buzzwords. And no, software-enabled is not software-defined.
Yeah, you bring an interesting point, but I guess OEMs might disagree that they like to say that their car matters, right? When you ask me, do you really care what kind of mobile phone you have? I think OEMs do care what kind of cars people are driving. But we're going to come back to that later, Moritz. Let's go to Ray.
Okay, that's unfair to put me on at the end, but but let me address. It's interesting when we talk about software-defined vehicles, and I like when it's the point about today the car when you drive off the lot is the best it's ever going to be. And the concept of the software-defined vehicle is that effectively it's the same as when you take your new tablet out of the box. This is it just starting. You're going to start adding all your personalized functions and your applications to it. And the limitation so far has been very much that what's been rolled out for software-defined vehicles has really just been that infotainment kind of smartphone part. The really interesting bit that I see is when it starts to become further into the functioning of the vehicle and the new capabilities that you can start to add by being software defined. The problem that we have in the industry today is that today's cars are based around kind of organically grown architectures that started maybe 30 years ago, and they are really difficult to update. So a lot of the work we're doing is on the new architectures that are designed so that they can be easily updatable and upgradable. And so that's, I love the idea of software-defined vehicles, but I think we're really just at the beginning at the moment. I think over the next 5 to 10 years, we're going to really see what they can deliver to both the customer experience, but also the economics of the whole car industry as well.
Very good. All right. So what I would like to do next is, I think everybody touched upon SDV from slightly different angles, but bring it back. I would like to ask you guys to help me understand different types of software that have roles to play in software-defined vehicle. I always joke that when Ray Cornyn in one of the panels, he said, well, SDV is not all about Angry Birds. And people are a little confused that there's an application software, the software that runs on cockpit, and software runs inside the car, real-time operating system, and then some middleware inside the car. So break it down for us, Jeff, first. What are the different components of software inside software-defined vehicle?
I think where you started was around the application layer, which is where consumers see, right? So that is your infotainment, in some capacity, the instrumentation cluster. And those are considered applications that perhaps the end user has visibility and interacts with. But there's a whole host of layers, what we call underneath that application layer, that makes it possible. So there is a cloud component, right? There's an orchestration layer. How does the car interact with the cloud? There's, I think that's an important layer. We happen to call that layer a control plane, right? Where now you're really decoupling how you orchestrate and how you communicate between a fleet and individual vehicles. So that's one layer.
Yeah.
Going down, there's what we call the middle layer, right? And I think middleware has a very, very broad term in the industry. And that includes things like hardware abstraction, for example, which is an important layer. And that's important for SDVs to basically become these flexible platforms, as you have to somewhat isolate the different layers of software from the hardware. So that's an important component of software-defined vehicles. And in that abstraction layer is what we call infrastructure services layer. And that's where, as you abstract hardware, you need to pool hardware, which means you treat them as an abstract resource, which means you have to secure them, which means you have to isolate them. And that actually provides the services for applications to run. And below that layer becomes things like the operating system layer. And those are a little more ECU specific that sit underneath all of the other layers. So that's kind of how we view the software stack. And I would love to hear how my illustrious panelists think about it as well.
Yeah, that's a very good overview. It's a, it's really top-down sort of view of the software architecture. So please chime in that your slightly different take on the software layers that you see in software-defined vehicles.
I think the architectural laying is pretty accurate that Jeff gave. I think there's a bit of a different view that you can take on that grouping. When I look at functions that I have in the car and how often I expect to see updates from a customer perspective, there's significant differences. When I look at the classic infotainment stuff, like when we talk about putting TikTok in your infotainment, right? The update frequency is probably going to be like on a daily, weekly basis, very customer driven, very little automotive grade qualification that you need to see. But still, those functions will need to get access to vehicle data. So when we talk about things like, delivery to trunk functionality, for instance, you need to interact with the physical device still. Then there's functionality that is highly differentiating for OEMs. When we talk about the next generation of an ADAS system, requires a lot of performance, certainly will sit on performance controllers, so POSIX operating systems playing a big role in these parts. But you have inherently automotive processes for qualification. Update frequency will be lower, yes. But because it's so differentiating, everyone will still push to get these functionality into existing vehicles in the field because it actually tells them apart from the rest. Then when we look at zonal architectures, you have those real-time controllers, the bigger ones, where you actually will need to have updates because you may need to change data rates of cameras for the next-gen application. But again, we're talking about real-time controllers, so the design process is a bit more intricate, validation is a bit different, so probably we'll have even slower update cycles. And then there's the world, well, washer, wiper, or these kind of things. Well, I'm not even sure whether you actually need updates or whether it's just going to be a smart sensor or actuator, but it's a different beast. And what I see in the EE architectures is that we start grouping more and more according to the update cycles rather than functional domains, so that you can manage the software with high change needs in the same kind of manner. And I think this is where the architectures are really going to change in comparison to what we've had in the past, because you start moving some functionality over from real-time controllers to HPCs because you don't need the real-time, but you actually want to get this fast update cycles.
Yeah, I think you're getting into this really important areas where I think you're talking about two things. One is, from my understanding, is how often do you does your software needs to be updated? That's number one. Number two is that mixed criticality. Some software needs really, you have to take care of the safety, security, while the others are not so much, right? So I think that I'm going to go straight to Ray at this point, because you guys have been actually given a lot of thoughts about mixed criticality and that sort of, the architecture of the SDV itself.
Yeah, and certainly, and Morit's point about, the different update rates, and, you've got, you'll call it mission critical applications that run on the vehicle, and you get maybe more infotainment customer items. And, one of today, they tend to be separated into individual ECUs. So the actual influence in each other can be kept fairly limited. But as you move to more centralization, you're having to develop architectures that can understand, the different level of criticality between the different tasks and be able to isolate. And maybe this is an ASIL D safety function, and it needs to run in this critical domain, and maybe this is an infotainment one. But you do want to be able to kind of still centralize those functions, because today in most automotive applications, the actual function will be in a discrete ECU. And most of the ECUs have very limited upgradability. You can't suddenly go, I've got this wonderful braking function, but it's 14 megabytes. And you go, the braking controller's 2 megabytes. So if you start centralizing, you get a lot more flexibility. But to do it, you have to understand you're now dealing with mixed criticality tasks on the same piece of hardware. So that's a lot of work we've been doing on new architectures. Is all about having to accommodate that and ensure a safe and reliable system.
Yeah, that's a good point. I'm going to come back to Robert, because I was telling you just before this recording started, I started to read the SDV for Dummies book that I put together. And in that, there's one sentence that really kind of caught my eyes. It says, up until now, software inside the vehicles are tied to vehicles model, year. It was really tied to hardware. And things are really changing, right? So let's talk a little bit about that from where you sit at ARM. How the software needs to be, if you think that software-defined vehicle is more universal and updates that need to be done, not just one specific chip from company A, but chip for 10 different companies. How do you manage that? And is that where Sophie comes in? Can you explain a little bit?
Ooh, okay, so we'll probably take the rest of the podcast to get this sort of. So what's interesting is, your traditional software stack, even an ECU, it hasn't changed. There's an operating system, there's some middleware, there's an application. Okay, that and it all runs on a piece of hardware. What's changing now is the need for different types of technologies or methodologies to allow for the updatability of software, for software to run at different criticalities on the same hardware system. And that's what we're doing in SOFI. We're bringing in concepts like containers, orchestrators, virtual machines, virtualization, which basically allows your software still doing its particular function, but to reside in an environment next to something that's doing a different function on the same piece of hardware. And so that's a lot of what we're doing in SOFI, is trying to put the mechanics in place of new software technologies that haven't traditionally been in vehicles. Vehicles on an ECU, they don't need to run containers right now. But as soon as you go to that different architecture, then you will need to have things like virtual machines and containers to separate the functions from each other. And that's where kind of Ray was going. So this is really what we're looking at in SOFI, is how do you easily take these software functions and update them, upgrade them, maintain them, in the same way you would for something like a cloud application or a smartphone application. And that's the difference. It's sort of these underlying technologies that haven't been in vehicles before that we believe are going to be needed for the software-defined vehicle.
Let me add one thing to this. This is looking at it from a technology perspective, how to enable the infrastructure. What is really important, if you buy into that value proposition that you're going to change key functions independently of the underlying hardware, independently of the underlying operating system, the key important point is to be able to decouple life cycles. So right now, a lot of times the way how ECUs are built vertically integrated means you change one piece and you need to change 10 other ones. And now we see that big consolidation of functionality, bigger controllers, and you want to increase the update frequency. And inherently means that you need to make components independently updatable. And these technologies are one of the key enablers. But another point that also contributes to this is backwards compatibility, control of APIs, control of SDKs. When we look at the successes that we've seen in the smartphone market, a lot of this is due to the fact that the apps from 5 Android versions ago still run today, because you don't need to update all the apps, although the operating system underneath changed. You don't need to update one app because you installed a different one. So really the decoupling of life cycles of software, of the software platform, and of the hardware platform. That's one of the key points. And the changes that we see in the software infrastructure, as Robert pointed out, these are enabling technologies to allow this decoupling. But these technologies are not the only point that you need to do to achieve that decoupling, because development practices, that's really one of the key points to enable that.
Yeah, and I love this conversation. I would like to add a couple of things. One, Robert, I'm waiting for a signed copy of your book, so I don't have one. And I'm looking forward to that. So hopefully I get one soon on my desk. So next time I see you, can I ask for a signed copy by you of your book?
Yes.
Second thing is going back to Ray's comment about how important it is in the hardware to support resiliency and uptime, basically, I think becomes even more important as you start consolidating the hardware. And I think that's where there's an interesting collaboration between software vendors in the infrastructure middleware space with our friends in the in the silicon hardware space, because as you start to consolidate, your failure domain also consolidates, and you have fewer failure domains. So how do you handle that? And that's where I'll get back to things like virtualization, like all of the panelists have talked about. Because that's a very important part of abstracting the hardware and decoupling the software and where it runs, and how do you provision hardware, and how do you isolate applications. And when an application fails or a piece of hardware fails, how do you react to that? How do you move the application from one piece of hardware to another? How do you restart the application? Containers are well known to be able to be quite resilient in that regard. So I think all of these technologies come together and solve all of these problems. So it's definitely technology that hasn't been there in vehicles before, but they're definitely appearing now, and I think they're definitely part of the future of software-defined vehicle.
Yeah, this is yeah.
Can I just say something in that
Sure.
in response to Jeff? Because one of the things that I think a lot of people in the industry, they kind of look at it and they go, well, my mobile phone runs lots of applications together, and that doesn't seem to be an issue. Why is it such a big issue for cars? Well, there's such a big difference in terms of if you have an application in your phone and it takes half a second longer to start up or shut down than it's just. If you start talking about, an ADAS system or a braking system, you don't have that. You have milliseconds to make the right decision. So that idea that you can isolate these tasks in a very secure and safe manner is important. It's important both for the hardware development and the software development. But it's a difficult problem to solve. But it's one that there are now hardware and software techniques that can solve it. But it's not just my cell phone can do it, so therefore, why can't my car do it? It's a very different discussion.
I'm glad you mentioned that. That's a fundamental difference, right? Because I'm a reporter, and every time when I talk about SDV, people want to talk about iPhone is in the car, or the data center is in the car, server in the car. I actually recently heard that HBM on the cars. But anyway, set that aside. I think a lot of people see that the different technologies coming into the vehicles, but I think we're touching upon very important issues here. Fundamentally, in your opinion, what's the difference from the iPhone software updates versus SDV software updates?
Well, I'll take a stab at it, and I think one of the biggest difference is just the amount of hardware and the number of components that are in the vehicle versus a cell phone. A cell phone is one entity; it's an endpoint. Whereas in a vehicle today, you can have upwards of 200 ECUs. Sure, that's going to consolidate, but I think probably what's going to be likely is maybe it won't go down to one ECU, maybe it'll few ECUs. But you'll still have things like a modern network that's in a vehicle that connects sensors and ECUs and different functionality, and that does not exist in a cell phone. So when you're talking about updating what essentially is a distributed system, it's orders of magnitude more difficult and complex and brittle than updating, a single platform, a single CPU that exists like in your laptop or your cell phone. So very, very different set of problems, very, very different set of requirements.
All right, I'm going to go to Robert because Robert, ARM is the king of the software. The smartphone market. So where do you see that the difference that you have to provide for the OEMs who are looking for SDV implementation versus, the smartphone companies who are using ARM to make their smartphones?
So it's interesting because there are certainly some things that we can take from both the cloud world and the smartphone world when it comes to updatability, when it comes to agile development, all that sort of stuff, which will benefit the SDV. However, the car is essentially a heterogeneous compute network, and the same for software. So your smartphone has one operating system running on it and a bunch of apps. Okay. Your car will have multiple operating systems. It will have AUTOSAR operating systems like Elektrobit provide. It will have Linuxes. It will have Androids. It will have just different types of real-time operating systems. And that's just the OS layer. And then on top of that, you have different middleware functions. You have different networks. It's a really completely different beast. And let's throw in real-time and safety critical while we're at it. So it's just completely different. It's the most complicated piece of electronics that you will ever own, and the most diverse amount of software applications, middleware, operating systems, and everything else that you will ever own. So it's really, really different. And that proves very interesting challenges for people that are making their vehicle, software defined.
Yeah.
Robert, you've touched on a very important point, the one of diversity in hardware or of the system. So I think actually the industry has done a very poor job over the years to reduce number of variants in vehicles. When I look at how many different suppliers, how many different chips, how many different software platforms are even residing within a single vehicle, let alone over different vehicle generations, that significantly adds to the complexity. I mean, if you now take something like a braking function that is distributed over several ECUs in the car, and now you want to make an update, to how many different companies do you need to talk to make that change? And this is one of the fundamental issues, since the industry has regarded software as an enabler for hardware pieces that you plug together. They never really looked at that. And now once you start doing software updates, you need to look horizontally, not at vertically integrated pieces of hardware. And once you do that, you really need to start reducing variance. And I think this is what we see in a lot of the EV startups today. It's reduction of EE architectures, really a lot of consolidation. With all those automotive software platforms that we see across OEMs, it's about consolidation of software assets. We don't want to have 5 different POSIX systems within a single vehicle because it doesn't make sense, because you still need to manage that complexity. And once you start updating, you need to touch each and every one of those. I mean, just imagine having a common Linux vulnerability and have 5 different distributions in your car. Well, you start analyzing the same stuff 5 times. So that doesn't make any sense.
Yeah, I hear the pain in your voice, Moritz. And I think part of the reason, Ray, you may be able to explain to us that the chip company is finally actually bringing together some of the platform-based solutions that actually applies to not just one single car, one single model, one single company, but actually you are actually trying to address the issue of the platform that actually pre-integrated with both software and hardware. Can you explain that a little bit?
Yeah, it's kind of interesting. One of the, when Robert was talking about, this is the most complex piece of electronics you'll ever own, which is 100% true. And one of the benefits that some of the newer startups have had is that they effectively been able to define that platform right from the ground up and do all their own software, and it's made that. And I always feel a lot of sympathy for the traditional car companies because they've got all these, platforms and complexity that they've got that has been built up over the years because they, maybe they sell 10 million cars, but they sell 400 different variants. And, the new guys basically do one architecture. So trying to get a platform that the car companies can actually work on. So we've been working along with a number of our partners on the idea of a software platform and hardware that then can be pre-configured with all the base software so that the car companies and the tier ones actually get to just work at the application layer that they want to work. So, we work with ARM and we work with EB on a platform that I think you'll have heard we discussed called NXP Core Ride, which is intended to try and take I'll call it the hassle, the complexity of just starting to build platforms and give a kind of pre-configured, easy to use software that customers and OEMs can start dropping their applications on. So yeah, that's part of our major focus. And it's really about let's make the stuff that's annoying and difficult easy for our overall customers.
Yeah, I would love to add to everybody's comments here, and that is, I think one of the challenges. Well, first of all, I agree with all of these points that it's a heterogeneous system, like Robert was talking about, and how there are all these different disparate. Everybody's doing their own thing that Moritz was talking about, and I think one of the challenges is the culture aspect. Traditionally, automotive OEMs, tier ones have been organized in these silos where everybody is responsible for a very vertical solution, a component. And when you're talking about software, it does, a modern software architecture is spanning across all the different hardware components. And so you do have to think horizontally. So how does an OEM in the tier one break down these silos and change their culture in order to build and accommodate and integrate modern software architectures? I think that's going to be a big, big challenge.
Yeah, it's a huge issue. And yet, because it's not really a technology issue or technical issues, it's often less discussed. But if you talk to any OEMs or designers who working in SDV development environment, that is really the first issue everybody brings up, right?
Yeah.
Yeah.
And Junko, we talked earlier about the number of ECUs and the idea that now functions are spread across ECUs. We saw a case with one of the OEMs, and they had a really nice function they wanted to add to their vehicle, but the function involved 15 different ECUs from 5 different teams and 10 different tier ones. And so they had this idea, and they then realized that they had to put 15 change requests for software updates and hardware updates. And if you think the whole idea behind software-defined vehicles is if you can actually free the data, free the functions, you can then actually do that as a single function. But at the moment, some of this stuff is a little bit of a nightmare in trying to update, I'll call it today's vehicles. And with, as Jeff said, with the business structures that are currently there's a lot of things that need to change to make this all work. But it's funny because I was thinking we're all sitting here going, yeah, this is why it's complex, this is why it's difficult, but we need to remember the pot of gold at the end, which is all of the functions you can do and all the potential revenue streams for the OEMs and tier ones and software companies as we go forward. It's kind of difficult at the moment, but the opportunity in the future is huge for everyone.
I like this pot of gold thing. All right, so this wasn't a part of my original questions to you guys, but since the CrowdStrike fiasco happened a week ago, or actually more than a week ago now, this is actually not so different from what we are trying to achieve in the automotive industry in terms of software updates. And without OTA, software update, I mean, SDV is not equal to OTA, but without OTA, software-defined vehicle, parts of the things that we are just talking about in this discussion won't be enabled. So tell us, what is your takeaway from what happened with CrowdStrike? Or is there any lessons you are actually taking from that incident?
When we look at fleets of cars, that's critical infrastructure for any country. And now our goal, as we said, is reduce variance, harmonize software architectures to actually make more things the same. That will also amplify the impact that erroneous software updates will have. Right now, if you bring out a software update for a certain vehicle generation, well, typically people need to drive to the garage, and you'll probably notice very early that the cars don't drive from the garage anymore when something goes wrong. So it's the impact of an update gone wrong is fairly low. With widespread OTA and harmonized software architectures within the vehicle and across vehicle generations, the impact of such a situation will multiply. And I think this is also one of the reasons why automotive qualification, the qualification standards that we do have in place, still remain very relevant. I think that regulations like the UNECE R155, as challenging as it is for the industry, is very much needed, because we are in charge of a large piece of critical infrastructure for every country that is absolutely vital to any economy. And we cannot risk having ransomware attacks on this critical infrastructure. So really getting proper software handling into these pieces of critical infrastructure is absolutely essential.
I think this is all part of the story of consolidation, right? When you consolidate everything, hardware, software, control plane. In this case, it was more about the control plane being consolidated. Your failure domain increases. So that means when there's a failure, it affects more components, it affects more vehicles, it affects more people. And I think that's one of the areas that, there is a trade-off between consolidation and resiliency and agility. And that's one of the things that the industry and the technology has got to mature more. Otherwise, it's going to affect all of us.
To close, I think I would like to end this discussion with the upbeat note and with Ray's pot of gold analogy. I want everybody to tell us, what is your dream? What is the pot of gold you're seeing within your company and for the industry?
Okay, so the nice thing about the pot of gold, as Ray talked about, is the car architectures need to change, the hardware architectures need to change, and the software architectures need to change. That's an opportunity, I think, for all of us. From an ARM perspective, what it means is that we need to keep delivering kind of high-performance computing IP for the automotive world. And something we did earlier this year is we launched our first server class automotive CPU. And so we're basically saying, okay, we can see this change is coming. We can see you need more high performance compute in the car to actually power the software defined vehicle. We can see that there's a software architecture that needs to change. So we're doing things like SOFI. So for us, there's a kind of real opportunity, working with our partners like Sonatus, like NXP, like Elektrobit, to actually monetize this change in architecture and allow the OEMs to then basically do the same. So I think it's a huge opportunity right now.
All right. What about you, Moritz?
I think when we again come back to the initial point of the value proposition of an SDV, creating new value for end customers, really changing the nature of the device, what it actually will become, the software-defined vehicle, is an innovation platform, not a software platform. So when I think back on the revolution that we saw in smartphones, when I saw the first smartphone, I would have never thought about an app like Shazam. And I think also the handset manufacturers would have never had a business case to build such an app. So the key point was opening up development environments and letting other people innovate on that platform, not looking at it as a fixed product, but as an innovation platform. And I think that's the ultimate vision. And for us as Elektrobit, it's really to enable everyone to develop software for vehicles as efficiently as possible, to get to the convergence of technology between cloud and in-vehicle infrastructure, and really enable people to develop software irrespective of now whether it has safety properties required, whether it has real-time properties required, whether you want to go for the most astonishing cockpit experience or app from an infotainment perspective. For us, it's really about creating that opportunity for innovation for other stakeholders in that industry.
Very good. Well put. What about you, Ray? You're the one who started the pot.
Yeah, the pot of gold.
Yeah.
No, it's funny that Moritz comment on, the analogy with the mobile market when, who would have thought when the mobile market came out and there was a camera with a flashlight on it that someone would have gone, you can build a heart rate monitor out of that. Oh, okay, that's great. You got a pulse. Oh, that's out of that. Now think what you're going to do in automotive. There are hundreds of different sensors all inside your car today. And the problem with them is a lot of their data is isolated. Or you get it, but it's low data rate, or something like that. So if you go to a properly software-defined vehicle where you've got access to all that data, and you might be able to do some software-defined networking and say, well, that sensor I now want, 500 megabits of data from. You can then, if you have it as an innovation platform when you've opened it up, think of all the creative people out there who are going to look at those sensors and think, I know what I can do. I can actually, I can use this to monitor all the road conditions, and I can then, source it to big data. And there's just all these kind of opportunities that are there once the right hardware and the right software platform is placed. And I think we're taking small steps today. We're getting there, but in the next 5 to 10 years, I think that, that pot of gold is going to be open to everybody in the car industry. And I think it's just a brilliant opportunity for the industry, but also for the end consumer who will start to see the benefits. I don't think we all know what they are yet, but we can see the history of what happened in the mobile market to know that can also happen in the automotive market. Okay.
Excellent.
I think Ray nailed it. It's once you have an innovation platform, the exciting part for me is you don't know where it's going to go. I think the next generation is going to define how we live our lives and how we interact with each other and how we get from point A to point B. It's not just about transportation. So I've been a part of many transformations across multiple industries, from finance to media to retail. And I truly believe that the transformation of automotive is going to be bigger than all of them combined. And where this is going to go, I think it's not just a pot of gold. It's like N number of pot of golds where N could approach infinity.
I agree with that.
and everybody's going to benefit. So to me, that's the exciting part of things.
Yeah. It was great. Thanks for coming to the panel. And I think this is only the beginning. I hope we'll have the chance to get together again to compare the notes and how far we have come and what hurdles we still have to overcome. Thank you.
Thank you.
Great. Thank you.
Bye. Hi. Thanks for joining us for the special Q&A session with one of the panelists of the software-defined vehicle software side of things we just talked about. We've got Jeffrey Chou. He's the CEO of Sonatus. Hi, Jeff.
Hello there.
Well, thanks for coming to the Q&A session, because I think there was a lot to chew on in the panel we just did. And I just want to start to ask you with this question, because this popped up during the conversation on the panel. I think you're the one who used the terminology software-defined vehicle. You know, you describe software-defined vehicles as an innovation platform. What do you mean by that?
I think innovation is, generally speaking, about bringing new ideas, new methods, new products, new services, and solutions to market, right? It could be around technology, innovation that is, but it also could be around business models and revenue streams and cost savings. The beneficiary of such innovation is broad. It could be consumers, it could be the OEM, but it also could be downstream suppliers from the OEM, or dealer networks, or even tangential industries like insurance, finance, and media. So, you know, that's my definition loosely of what innovation is about in automotive. And the platform is the enabler. It includes the hardware, the software inside the vehicle, related to connectivity, the cloud. In an abstract sense, the platform could also include the ecosystem of players and the protocols and the standards. So an innovation platform, imagine where there's a world where the ecosystem of innovators is large and broad, and the vehicle or the fleet of vehicles is at the center of delivering those new ideas and innovation. To me, that's what an innovation platform is all about.
It actually is a very broad terminology, isn't it? You're talking about innovation not only in technology but also in business models, correct?
That is right. And it's about, you know, a platform could also be a partnership, right?
Yeah.
How do different entities, what is the platform in which they communicate and deliver innovation? I think that's all part of an SDV, which is going to be very important moving forward.
Yeah. All right. One of the things that struck me while I was moderating the panel is, geez, this is a really complicated topic. It's easy to say SDV, but in fact, there are a lot of moving parts. You know, there are a lot of the stuff that I see sort of like a chicken and egg problems. So from where you sit, what do you think must happen first?
Well, I think SDV is an evolution, and from a technology perspective, well, there's two ways to think about this. Let's talk about the technology perspective first. I think the hardware and the software are evolving together. I don't think it's necessarily a chicken and egg. I don't think one can come before the other. EE architectures and their components, from silicon to ECUs and connectivities, they're certainly the foundation of what features are enabled in software. But software also, you know, pushes and requires more advanced hardware. So both sides are taking kind of their steps together. And that's why it is an evolution. It is a journey. And that's, you know, that's how the technology is built up from the ground up. But then you also have organizational and cultural issues that need to be addressed in the OEM and across the entire ecosystem down to its suppliers. So those are also an evolution because you have history there. I mean, it's been a successful industry for a century, and some of that culture is evolving as well. And I think that is important, as important, if not more, than the technology in order to reach the destination that we want to reach.
Yeah. You know, that's a very important point, because while I was doing the series of SDV Deeper series, this, you know, thing about cultural issue or the organizational issues brought up practically by every executive. And I used to think, well, you know, the cultural issue is kind of a solved problems. It's not really a technology problem. Do I have to cover this? But then it dawned on me, this is a huge issue. I mean, this is the issue that every OEM is facing today, right?
Absolutely. And I think it's so ingrained in business models and cost structures and culture that it is difficult, because you're talking about the livelihoods of people and how they conducted their careers, and you're talking about how different organizations and companies were built, and how do they make money, and how do they add value. So the transformation in technology is going to transform all of the culture and the organizational structure of this industry, and that's going to be a challenge.
So I don't want to put you on the spot, but we see a lot of companies out there in the market who are claiming they've got SDVs. And I think people may have different opinions. Can you give me an example of SDVs that you've already seen on the market today?
That's an interesting question. I think the term SDV will continue to evolve, and certainly even the most advanced data center that is supposedly the most advanced in software defined, the state of the art is continuing to improve. We've got a lot more to do. And SDVs just started not long ago. I think the most advanced SDV vehicles have not necessarily incorporated all of the software defined technologies that existed even in data centers since the early 2000s. So I'm hesitant to consider any vehicle on the road fully an SDV, but certainly there are many vehicles that incorporate some of the important aspects of an SDV, such as over-the-air updates and maybe an early application framework for an infotainment. But these are still very early, right? There's a lot more to an SDV that we have to improve upon.
Yeah, that's true. All right. I see one question from our audience. This is very interesting. As was the case with the Boeing 737 MAX and the two major crashes, where the MCAS was used as a software fix to mitigate issues with hardware, in this case, engine placement, design, and minimizing pilot training. Do you foresee something similar to this problem in automotive companies resorting to kind of suboptimal, hardware design with the plan of fixing them with software down the road? And it's okay. We got software-defined vehicle. We can fix it, right? But it may not work that way. How do you see this?
Yeah, that's funny. My background is from the data center side, and much of what we did was basically under the assumption that something is going to fail. Whether it's connectivity, whether it's hardware, you have to architect your software to assume the underlying infrastructure foundation is going to fail, right? So some of this can be done in software, where you do have things like resiliency. How do you handle failures in real time? How do you do active failovers? How do you use technologies like virtualization to insulate some of the failures? So some of this can be handled by software. And the goal that we had is to handle more and more of it in software, because to deal with hardware failures is expensive. And in many cases, as per the question, there's a safety issue as well. So I think it's not just a question of a hardware solution, but software is going to be a big part of solving faulty hardware or field failures, right? And so I think there's a lot of advancements in software to mitigate that.
Well, that means that how you how do you design software becomes even more important. In other words, what I'm actually afraid of is that now that we can do the software define, software updates on some of the cars, I think car makers may be thinking less about the resiliency of hardware because, well, they might have some, problems with this hardware, but we can fix it down the road by software. That using software updates as an excuse, but what you're saying is that software itself needs to be designed upfront much more rigorously. Is that what you're saying?
That's absolutely right. And in many requirements in the IT world, we have uptime requirements, right? 5 nines, or in some cases 7 nines or 9 nines.
9 nines, yeah.
How do you do that, right? You can't assume that the hardware is going to be up 9 nines. So how do you architect and implement a software overlay or infrastructure that accounts for hardware failures? Now, I know in a plane, in vehicles, that hardware requirements and hardware resources availability is very different than in the cloud. That's certain. But that's part of the SDV challenge, is how do you adopt some of those ideas and philosophies in the IT space and apply them to automotive? I mean, there is a solution. We will get there. But all of these different requirements in all these different industries, software plays a major role in resiliency and recovery.
Yeah, that's good. Well, actually, speaking of which, we had a session yesterday between Phil Coltman and Brian Weimer, and this was about the life cycle of AI-enabled products. And I think that, that could be smartphones, but that could be also SDVs, right? One of the issues was, sure, the software updates, great, because it's necessary, as you said. But at the same time, hardware would not keep up with it. In other words, that especially in the AI world, when there's so many models pop up, we're now talking about the large language model, but who knows, 3 years from now, our hardware in the car might have to deal with some other models beyond LLM, right? So how do you deal with this mismatch of the more advanced software coming in and hardware inside the car may not keep abreast of it? What's your view? Because I think the worst case scenario for OEMs would end up breaking their own car 10 years from now.
Yeah, I think there will always be a rate at which software advances and a rate at which hardware advances, and they won't always be lockstep. But they do in some ways have to be in sync, or else you will have issues that you were just referring to. But we've had AI or similar types of AI in vehicles for a long time. In many ways, you could say your ADAS incorporates some AI in it, right? So it has to be intelligent and has to recognize lane departures and act upon it. So there's definitely precedence for having AI in a vehicle on existing commodity hardware in a vehicle. So I don't think we're starting at zero. I think the challenge is going to be how do you size AI solutions to the hardware availability in a car. And there's a lot you can do with AI in the current hardware in the car that still adds value, right? AI is not just about autonomous driving. There are many other solutions that can be built that require a small model, such as how do you diagnose your car, right? Yeah. How do you personalize your car? Yeah. How do you improve the dealer experience, or how do you improve fault recovery or redundancy? Those kind of things that are a little more bite-sizable, as opposed to incorporating an LLM, for example, could be interesting initial solutions to the hardware that's available in the vehicle. Right. But it's kind of like, your hard drive space, right? Everybody always thought, I'm buying a bigger hard drive. What do I need it for? Well, the theory is it doesn't matter how big of a hard drive you have, you're going to fill it with something. Yeah. So hardware is the same way. It doesn't matter how how much processing power or memory you have, you're going to use it for something.
Or something, yeah.
And I think that's where SDV and AI will help shape hardware requirements going forward, and hardware features will shape what AI models can be run in an SDV.
Yeah, I think with the point, the understanding we must have is that it's one thing to talk about the life cycle of hardware, right? Because chips do get old over time. And it's another thing to talk about availability of software updates. And yet software itself needs to be designed upfront, knowing there will be a limitations of the life of hardware. Is it right?
That is absolutely right. It's limitations of hardware and hardware failures, right? And maybe there will come a time in the future where we not only have software updates, but maybe we have hardware updates.
Yeah.
Of course, that's going to be harder and more expensive, but I would love to be able to upgrade my IVI in my older car, or upgrade the memory or processor so that I can have more software features.
Yeah.
So maybe we get to a point at some point in the future where that's doable and commonplace.
If it is designed from the get-go that this thing can be replaced, I mean, the IVI is designed in such a way that I can swap my IVM, right? IVI.
Yeah, and I think that's one of the benefits of software-defined technologies is that you can change things hardware-wise in a vehicle and have the rest of the hardware and software recalibrate, if you will, or reconfigure. It's just like when you change out, you add another laptop or mobile phone to your Wi-Fi. Yeah. Things generally speaking, the idea is it just works, right? It's a new piece of hardware that's incorporated to your network.
Yeah.
How does the network reconfigure itself to incorporate a new piece of hardware? Ideally, a vehicle should be similar if it incorporates the right software-defined technologies.
All right. Very good. Well, I can talk to Jeff forever, but thanks for coming to the Q&A. This is most enlightening discussion. Thank you very much, Jeff.
Thank you. Glad to be here.
All right. Talk to you guys soon. Thanks for joining for the Q&A session. Bye.